Alright, so I touched on the inverse in a previous example, but let's take a look at it again. So let's take the point 3, 2, xy, and let's call that f of x, or x, f of x, whatever you like. And let's say g of x is a transformation of f of x, and it's equal to f inverse of x. That notation, that -1, is inverse notation. So I'm going to always write my point down, 3, 2, and I'm going to say what I'm going to do to it, f inverse. And that means that x and y switch. So I simply switch x and y for the point 2, 3. And if I switch x and y and find the point 2, 3, it's right here. 2, 3, our new point. Just simply switching x and y. Very simple method. Most people mess it up. They think too much about it. Just switch x and y. If I get a point, I just switch x and y. If I get an equation, I just switch x and y. And we're going to see that next. All right, a second ago we saw what we are doing with the inverse, and that's switching x and y. So now let's take f of x equaling 2x plus 2. So I like y equals, so I'm going to go for y equals 2x plus 2. And I know that the inverse method, f of -1, is switching x and y. So if I switch x and y exactly as it sounds, anywhere I see a y, I put an x, and anywhere I see an x, I put a y. Switching x and y. Now usually we want to solve this equation. So if I simply do my algebra and I subtract 2 from both sides, I get x minus 2 equals 2y. And then if I divide both sides by 2, I get x over 2 minus 1 equals y. And feel free to mirror the equation and call it y equals 1/2 x if you like, or whichever. But basically, y equals 1/2 x minus 1 if we mirror it. Some people like it better that way. So as you can see in the notes, let's graph both of those. So from grade 10, we have the equation y equals x plus 2, 2x plus 2 with a y-intercept of 2 and a slope of up 2 over 1, and the same slope in the opposite direction. And then our new equation, y equals 1/2 x minus 1, so we have a y-intercept of -1. And I'm going to draw that line on the last one a little bit better for the purposes. So, and then again, the new equation, y equals 1/2 x minus 1. We have a y-intercept of -1, and we have a slope of 1/2. So up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2, and draw that line. And if you care to look at the table of values in the notes, we have a point like 1, 4. Switching x and y to be 4, 1. A point 2, 0, switching x and y to be 0, 2. As we said before, we were going to do the inverse. Keep in mind, we have new notation. So where we wrote the old equations, I'm just going to write the inverse notation. f -1 of x is equal to 1/2 x minus 1, our new equation. We switch x and y in variable notation, and then finally write the new one. So our old equation was y equals 2x plus 2, and our new equation is our old equation, f of x is equal to 2x plus 2, and our new equation, f inverse of x is equal to 1/2 x minus 1. So we can either get an equation, we can switch x and y, or we can notice that it's just a diagonal reflection over the line y equals x. We've seen vertical reflections, horizontal reflections, now we've seen diagonal reflections. So in the notes, there's a way to check your answer, and that's putting the inverse into the function, or a reverse, and putting the function into the inverse. So let's take a look at that. So from the last section of the video, we saw that if we have f of x is equal to 2x plus 2, its inverse function, f inverse of x, is equal to 1/2 x minus 1 by switching x and y and doing all the algebra. Now we're supposed to check our answer. So a little bit later in chapter 10, we're going to be doing a little bit more on function notation, but outside of that, I'm just going to show you how we're going to do it quickly. First of all, we're going to take this and put it into this guy's x, and then we're going to take this and put it into this guy's x and make sure that they're both equal to x. So if we do the red first of all, and I take the one function and put it into the x variable to the other function and clean it up, I get 2 times 1/2 is just 1, so I get x minus 2 plus 2, and that's equal to x. And if that happens, we're halfway to figuring out if it's correct. Then if we go in the other direction and write down the other function, the inverse function, 1/2 x minus 1, and we take the other function and put it in for x. So taking this function and putting in for this x. Then we still have a plus 2 off to the right. Distributing, we get 1/2 times 2 is just simply x plus this should be a minus 1 off to the right. And if we keep on distributing, we get 1 minus 1, and those cancel, and we get x again. And that's the goal. We have to be able to make sure that if we put the inverse back in for x into the original, or vice versa, both of them have to equal x, and that is the definition of an inverse. Or switching x and y if you get the point, etc. Okay, let's take a look at one more example of an inverse. So y equals, I know it says in the notes f of x, but just putting y, making y f of x, and again I want to do the inverse, so I'm going to switch x and y. Everywhere I see a y, I'm going to put an x, and everywhere I see a x, I'm going to put a y. Then I'm going to times both sides, and remember, if I times both sides, the thing on the bottom just shows up here. So I have y plus 1 x equals y. I want to distribute backwards, and I get x, y plus x equals y. Now I want to get everything with y on one side and everything with x on the other. So what I mean by that, first of all, I'm going to subtract xy from both sides, and I'm going to get y minus xy, and I'm going to leave this x where it is. Simply taking this xy, subtracting it from both sides, and it's showing up over there. Then I want to factor out a y. Then I want to divide both sides by exactly what I factored y out of, and I'm going to do this one more time for you guys. And I simply get x over 1 minus x. These ones cross off, is equal to y. But it's going to be a lot simpler to read your notes and follow teachers if we don't divide both sides. And just take this thing and put it down below the other side, dividing both sides by it in our heads. Then we can mirror the equation and say y equals x over 1 minus x, and then we can call it the inverse. F inverse x equals x over 1 minus x for our final answer. Follow the instructions in the note, switch x and y, multiply both sides, distribute, combine all the y's on one side, factor, and divide.